Algebra Chapter 1, Lesson 3, and in this lesson we want to look at what we call exponential notation. Now, where have you heard that term, or kind of something like it, exponent or exponential? Well, you remember when we were talking about order of operations, the second thing that we need to do is to take care of exponents. Parentheses first, then exponents, before we then multiply, divide, add, and subtract. So we're going to take a look at exponential notation. What is it? How do we use exponents? What's their purpose? And then we'll look at evaluating expressions that have exponents. So here's a couple of paragraphs that discuss exponents. We're going to kind of jump around here a little bit, but we'll cover everything in here. Let's look at an exponent first, these words that are in yellow here. An exponent tells us how many times a number, so it's how many times a number is used as a factor, okay? And remember, a factor is just a number that's being multiplied by other numbers, okay? So an exponent tells us how many times a particular number is being used as a factor. If we look up here at this example here, we notice that 2 is being used as a factor over and over and again. Well, how many times is it being used? How many times is it being multiplied by itself? And it's being multiplied by itself 4 times. So this exponent tells us how many times this number 2 or any other number is going to be used and multiplied by itself. Now, this number that we're talking about is called the base. All right, so 2 is the base, 4 is the exponent. Okay, so if we broke that down a little bit, we have an exponent. It's a shortcut. It's a way to write the number of times that a number is being multiplied by itself. So it's a shortcut for using the same factor. And what it does is it shows how many times the number is a factor. So if we have 2 to the 5th, the exponent, which is the smaller number up here, tells me that I multiply 2 by itself 5 times, or 2 is a factor 5 times. All right? That's what the exponent tells us. The base, and again, this is very important, is a number that is a factor multiple times. So the base is this number that's being multiplied however many times the exponent tells us. So in this case, 2 is the base. So you have 2 parts that we were talking about here. We have a number or a factor, a number that's going to be multiplied by itself, and then the exponent tells me how many times that's going to happen. Okay, so that's the definition of an exponent, and that's the definition of a base. And it's very important that we get this down as far as the word base, because we'll use that definition quite a bit as we're talking about algebraic expressions moving forward. Okay, there are some other things in this paragraph we want to take a look at, so let's take a look at those. A couple other terms that we want to be aware of, this word power. And a power has 2 parts. It's a base and an exponent. Essentially what we're talking about here is whenever you see an expression that's in this notation that has a base with an exponent, we call that a power. Okay? And the exponent is the power. School's out. The exponent, did you see me jump there? That thing scares me. It's so loud. Anyways, the exponent is what we call the power, and the base is the base. And so together this makes up a power. So we would read this as 2 to the 4th power. Now I want you to take a note here. Notice that we have, this is the math language representation. This is 2 to the 4th power using math symbols. Notice that the translation into English is this. So we have this English phrase 2 to the 4th power. And again, we talked about earlier this year that math is a language. And we have math symbols that we use when we're writing things in math, and we have English symbols that we use when we're writing in English. And so we want to be able to translate this into English. And then if we were reading a word problem and we came across these types of words, we want to know, oh, well, that's talking about a mathematical expression that looks like this. Translating this word power into its mathematical expression. So that's that translation thing we were talking about earlier. Now, if we wanted to simplify this power, we would multiply the base by how many times the exponent tells us. So we multiply 2 times 2 times 2 is 16. I think I said 4 2's. If I didn't, I meant 4 2's. Okay. Now, sometimes there are special names for the lower powers, like anything to the third power we call a cube. Anything to the second power we'll call squared. So you can either say 2 to the second power or 2 squared, or 2 to the third power or 2 cubed. But again, notice the English translations, so you need to be aware of those when you're trying to translate those, or when you're asked to translate those. Okay, so very quickly then, a power is simply an expression that has an exponent in it, and the way we translate it is we translate the base to the exponent as the power. So in this case we have the base, which is 2. Notice I replaced this word base with 2 to the, and instead the exponent, I actually put the exponent is 4th power. So 2 to the 4th power. So some other examples of this would be something like, let me get rid of this stuff here so we can see this a little bit better. So 2 squared, or 2 to the second power, means I multiply 2 by itself twice. I use 2 as a factor twice. And we read that 2 to the second power, or 2 squared. N to the 4th means multiply n as a factor, use it as a factor 4 times. 1, 2, 3, 4. And we will read that as n to the 4th power. 3 to the 5th means multiply 3 by itself 5 times. 3 times 3 times 3 times 3 times 3. So 3 is a factor 5 times, and we read that as 3 to the 5th power. Okay, so that's what a power is. Now, anytime we have an expression that has exponents in it, this is called exponential expression, and that is a term we need to, again, be familiar with. This would be exponential notation, whereas if I wrote it all out like this would be what we call expanded notation. So the difference between the two, and we need to be comfortable with that, again, as we're translating and as we're hearing people talk using the math language, or using English to describe the math language.